We are on chapter number 3. Okay. All right. So last time we had started the Fourier series of periodic signals. Okay. So this was the expression for finding the Fourier series. So x of t is your signal. Okay. Let me try to show it through a laser. Okay, so this x of t, this is your signal, which is a periodic signal. Okay, remember we are talking about Fourier series, which is only for periodic signals. For non-periodic signals, we have a Fourier transform that we will talk about in the next chapter. Okay, so this is our signal x of t, and what Fourier says that you can write the equation of this signal as this summation, right? In this summation, everything is known except a. A is the coefficient. Okay, so this k is coming here from this summation, right? So k is known. Omega naught is 2 pi f. Okay, 2 pi is known. Okay, f is the frequency. Okay, and t is the time for this one, right? And then we did an example, if you remember, that this x of t is my periodic signal. Okay, which looks like this. This one. This is my periodic signal. Okay, and by looking at this signal, you cannot tell which frequencies are there in this signal. Okay, so how do we tell which frequencies are there? Uh, this summation tells us. This summation tells us that there are a total of 7 different sine waves that, when added together, will give me this signal. So for this 7 sine waves, these are the coefficients. A0 is given as 1. A1 and A minus 1 are 1 by 4. Okay. A2 and A minus 2 are 1 by 2. Okay. And A2 and A minus 2 are 1 by 2. A3 and A minus 3 are 1 by 3. Right? So what we did, we put all these numbers here in this equation and we expanded it just to see which frequency components are there. So when we did that, okay, after putting it in this summation and substituting the values of a's, okay, we came up with this, that this is the equation of our periodic signal, which is this one. Okay, now if you look at this signal, the first term here, the frequency is 0. So it shows that there is one signal having a frequency of 0, which is this one. Then there is another signal which has a frequency of 2 pi, okay, which is over here. Then there is another signal which has a frequency of 4 pi, just shown here. And then there is another signal which has a frequency of 6 pi, which is over here. So what we are saying, if you add this and this and this and this, when you add all these, you get this signal, right? So Fourier tells you that there were actually 4 different sine waves that, when added together, gave us this signal. Okay, so we had stopped at this point. We reached at this point last time. Now let's move forward. So as I said in the previous slide, that these are the unknowns. Okay, so our objective is to find these a's. Once we know these a's, we can write the Fourier of our signal. Okay. So How to find these Fourier series coefficients? In order to build a Fourier series, we need to find the coefficients ak. If the signal is such that the sinusoidal components are easily identified, it is easy to find ak directly from the given equation. Right? If ak cannot be found out directly, a formula is used to find ak. So basically what we are telling in this slide is that there are two ways of finding A. One way is that you look at the expression of your signal and the Fourier coefficients are very obvious. You can directly take them from there. We will do some examples to show this. But if your signal is not in that situation, it's a different type of signal where you cannot find A directly, then there are some formulas that we use, which is the second method. Okay, that also we will do. Okay, so now let's look at the examples of the first type. Let's suppose my signal is this. Find the Fourier series coefficients for x of k equal to sine omega naught t. Since there is a sine, so I know that I can directly find the coefficients ak's, right? How I can find that? If you can open this sine omega naught t using the formula that sine theta is e to the power j theta minus e to the power minus j theta divided by 2j. If you open it in that fashion, okay, you can okay, let me show it to you on how we do that.
Doctor,
Yes, go ahead.
you mean you will use Euler identity and sine?
Yes, exactly. Yes, that's what we do. All right, so basically what we are saying is that since sine theta is e to the power j theta minus e to the power minus j theta divided by 2j, right? So I can write it in this form 1 over 2j to the power j theta minus 1 over 2j to the power minus j theta, right? I can write it in this fashion, right? And the signal that was given on the slide was this one: x of t is equal to sine omega naught t. This was given, right? So what I can do is I can apply this Euler identity on this one, and this becomes e to the power j omega naught t minus e to the power minus j omega naught t divided by 2j, right? And then I can write it in this form 1 over 2j e to the power j omega naught t minus 1 over 2j e to the power minus j omega naught t, right? Now if you look at this and you compare it with the Fourier series equation, what is the Fourier series equation? Let's write that. X of t is equal to sigma k goes from minus infinity to plus infinity a k e to the power minus j k omega naught t, right? Now, if you compare this equation, this equation with this equation, right? So you can, what can you tell? What is the value of k over here?
Uh, 1, maybe?
1, exactly. Exactly, k is equal to 1. And how about here? What's the value of k?
Minus 1.
Minus 1. MashaAllah. Very good. So, since I know k is 1 here, so what is this? A What is this? A,
Okay.
yeah, and K is 1. So it is A1, right? And this guy is going to be A minus 1, right?
Yes.
So that's what we mean when we say we can directly find the coefficients in some of the signals. So these are the type of signals where you can easily find the coefficients AKs directly from the equation, right? Any questions? Is it clear?
Yes, it's clear.
All right. So let's go back to the slides. Okay. So then you can tell now that A1 is 1 over 2J.
Actually,
Yeah, go ahead.
there's someone called Muhammad Zahrani who's trying to request you to join this meeting.
Yeah, but I don't see him trying to join. There's nobody.
He told me he made a request to you.
No, no. I mean, he will. Google will show me when he tries to, because the way I entered all you guys, I'm gonna enter him as well. So it's there. There should be a pop-up coming here, asking me to admit him.
Okay, I will tell him.
So just tell him that I mean, you click on that link, and the request should come to me directly. All right. So here we can see that the coefficient a1 is 1 over 2j and a minus 1 is minus 1 over 2j. And how about the other coefficients? All the coefficients are 0, right? So whenever k is not 1 or minus 1, the value of ak is 0. There are only two coefficients, a1 and a minus 1. All right? Is it clear? Any question? Now this was a very simple signal, x of t only sine omega naught t. Now let's take a little complex signal. For example, this one. Now find the Fourier series coefficients for the following signal. When you look at this type of signal where you see sines and cosines, we know that we can directly find the coefficients AKs right from this equation using Euler identity, right? So what do you think? How shall we move? This number 1 will remain as 1, right? This sine omega naught t, I can open it using Euler identity, right? And what is Euler identity? Let me write here the formula so that you can use sine theta is equal to e to the power j theta minus e to the power minus j theta divided by 2j. This is for sine and this is for cosine, e to the power j theta plus e to the power minus j theta divided by 2. These are the two formulas that you have to use. So for this one, you will use the first formula. For this one, you will use the second formula. And for this one also, you will use the second formula. Remember, this whole thing is theta. Whole thing is theta. Okay. So give it a try. I give you, 5 minutes or 7 minutes. Okay. Give it a try. And then I will show you how to do it. But I want you to try it first. Okay. Any question before you start? All right. Go ahead. Give it a try and then let me know how far have you gone.
Doctor.
Yes, go ahead.
Uh, he told me he made another request from another browser. So I don't know if the
No,
request.
I still did not receive anything.
Okay.
What, let me, okay, give me, give me his email address. I will try to add him manually. Ask him to send me his email address. I mean,
Okay.
the email from which he's trying to enter. Ask him to send me his email, and I will try to add him.
Doctor,
Yes, go ahead.
I have done the sine and cosine, but I'm not sure about the one in the beginning.
You mean the number one?
Yes.
Yeah, one will remain as one. You will keep because one you cannot do anything. So it will be one plus, and then
Okay.
the sine omega naught t will be e to the power j omega naught t minus e to the power minus j omega naught t whole divided by 2j, right? But one will remain
Yes.
there, one plus, yeah. So one is the, this is the signal having zero frequency.
Oh, okay.
All right. So, how far did you reach? Anybody has any updates on that? Okay. Now let me show it to you how we do it. It's easy. Okay. Uh, so the next step is that we next step is that we open these. So if you can see that this one comes here as 1. Okay. This sine omega naught t can be changed to e to the power j theta minus e to the power minus j theta divided by 2j. So 1 over 2j I have taken out. Okay. And then this is cosine omega naught t multiplied by 2. Okay. So cosine omega naught t is what? E to the power j theta plus e to the power minus j theta. Then there is a divide by 2. But where has it gone? Can anybody tell me where is that divide by 2?
Let's go and when they multiply it by 2.
Yeah, this 2 has cancelled it, right? Okay, then plus this is cosine theta. So this whole thing is my theta. So now it will be e to the power j theta. This whole thing is theta. Plus e to the power minus j, and then this whole thing is theta. Whole thing divided by 2, and that 2 is outside. Okay, now let me know this first step. Is it clear to everyone, or is there any problem?
It's clear.
Okay, now what we do next, collecting terms. What does it mean, collecting terms? If you look at this e to the j omega naught, what is the value of k here?
1.
1. How about here?
Also 1.
Also 1, right? And that's it. So we have these two terms. For both of them, the value of k is 1. So I can take this common here, right? And with this one, there is 1 over 2j, which comes here, right? And with this one, there is a 1 here, which comes here. So that means that when k is equal to 1, the coefficient ak is this. A1 is this. Is it clear? Are you getting my point?
Yes.
Okay. Similarly, if you look at this one, here the value of k is minus 1. And here also the value of k is minus 1. And that's it. We don't have any other such term. So I can again take this common, right? So the coefficient here is 1, and the coefficient here is minus 1 over 2. So I take this common here, and I say 1 minus 1 over 2. That means this is now a minus 1. Right? Is it clear?
Yes, Doctor, but I have a question.
Sure. Go ahead.
Um, Pi divide by 4, is this the face?
Divide by 4. Where is divide by 4? Yeah, pi divided by 4. Yeah, this is, see, this whole thing from here to there, this whole thing is theta. 2 omega naught t plus pi by 4. It could have something else, minus 5 by 7 and whatever. Just, don't worry about whether it's a phase or what. This whole thing is theta. That's it,
Okay.
whatever it is. Yeah. Okay. All right. So now the next step is that we, after doing this, these two. Now let's look at this one, this complicated guy. Uh, if you look at this one, now let me write it down here so that it's clear. I'll just take this part, okay, separately and explain it, right? So I'm gonna do it here, in the other window. I hope you can see it. This is cosine 2 omega naught t plus pi by 4, right? Now let me make it larger, okay, so that you can see it. Okay, so this guy is equal to e to the power j theta, right? So theta in our this case is 2 omega naught t plus pi by 4, right? Plus e to the power minus j, and again theta, 2 omega naught t plus pi by 4. And then the whole thing is divided by 2, right? Now, if you look at the original Fourier series equation, okay, you can see that in the original equation we have this j k omega naught t, right? So if you compare this with this, we can see that here, if you look at this j 2 omega naught t, what is the value of k here?
2.
2. And similarly here, the value of k is minus
Minus.
2, right? But the problem is this guy. There is something attached to it, okay? So we'll handle it separately. So what we will do, we will say this is equal to,
Doctor, this isn't phi, doctor. Pi divided by 4 isn't
well,
phi.
whatever it is, phi or theta or whatever, but we have to take this one out, right? Because we just need this, okay? So we have to do something with this pi by 4. So it's going to be e to the power j 2 omega naught t, right? And I can write this as e to the power j. But can I do like that? Right? Because the powers are adding, so I can write them as multipliers is equal plus e to the power minus j 2 omega naught t into e to the power minus j pi by 4, right? And this whole thing is divided by 2, right? So remember, whatever is there with this term is AK, right? So that's what I'm going to do here now. You look at this is going to be equal to e to the power j 2 omega naught t, and this guy, this is my AK, right? So I'm going to write it like this, 1 by 2, right? E to the power j pi by 4. Similarly for the next one, okay, is going to be this guy here is a minus 2, right? So it's going to be 1 by 2 e to the power uh, j minus j pi by 4 e to the power minus j 2 omega naught t, right? So then I can say that, for example, this is like this and this is like this. So that means this guy is a 2 because of this 2, and this guy is a minus 2 because of this minus 2. Now tell me, is it clear?
Yes, doc.
All right. Any questions before I move forward? Okay. So now if you look at this equation, okay, you can see that this is what we did. So this is A0, this is A1, this is A minus 1, this is A2, and this is A minus 2, right? Therefore, the Fourier series coefficients for this example are this. A naught is 1, A1 is 1 plus 1 over 2j, A minus 1 is 1 minus 1 over 2j, A2 is 1 by 2 or j pi by 4, and A minus 2 is half rho minus j pi by 4. Okay, we'll talk about this now, but first let's first clear this. So tell me, is this clear? A1, A minus 1, A2, A minus 2.
Yes, doc.
Okay, now let me go back to some of the basics. Okay, uh, So what we have now is this. A0 is 1, so which is fine. A1 is 1 plus 1 over 2j. Now, if you remember, how do we write complex numbers? A complex number, a typical complex number is like this. For example, z is equal to a plus jb, right? So a is the real part and b is the imaginary part. This is the real part and this is the imaginary part, right? The problem is that in this expression, j is in the denominator, while j has to be in the numerator. How can I bring j up?
Make it j to the power minus 1.
Yes, very good. Exactly. That's what we should do. So, what we're going to do is we'll say that this guy is equal to 1 plus 1 by 2, and when we take j up, it's not j to the power minus 1. The rule is that j is the same as minus 1 by j, or 1 over j is the same as minus j, right? So whenever you bring j from denominator to numerator, it changes sign, or from numerator to denominator, it will change sign. So here, when this j goes up, this sign is going to change, right? It is going to change to minus 1, right? So now if I ask you, okay, one more question. Uh, if I give you this complex number and I say, what is the real part of this complex number? What is your answer?
1.
1. Okay, then my next question is, what is the imaginary part of A1?
2.
Half.
2 half. Anybody else? Both are wrong. Both are incorrect. Anybody else? See, look at the basic definition. This is the basic definition of real and imaginary parts. That when j is in the numerator, then whatever is there is the imaginary part. Here j is in the denominator. So first you have to move j up like this. And now you can see that the imaginary part is
Minus half.
minus half, right? That's very important because, if I give you this complex number in the exam, I'm talking about, this number. And I say, what is the imaginary part of this? And if you say 1 by 2 or 2, you'll be wrong. Okay? So whenever we talk about the imaginary part, make sure that j is in the numerator. Only then you can have whatever is there with the j as the imaginary part, right? Is it clear?
Yes, doctor.
Yes.
Any question? Okay. Similarly, we'll do the same thing with the other number, which is a minus 1. A minus 1 is 1 minus 1 over 2j. Now you tell me, what should I do with this? It should be 1 and then
Minus half.
Plus half j.
plus half j. Why? Because this j, it moves up. Okay, when it moves up, it becomes negative. When it becomes negative, that negative and this negative become positive, right? Is it clear?
Yes, doctor.
All right. So then A1 and A minus 1 are clear. Now let's look at A2 and A minus 2. The value of A2, as we had written in the slide, is 1 over e to the power j pi by 4. All right. What can I do with this? Can I do something with this? Can I simplify it? Okay, hint, use Euler. Then
Maybe if we change it to sine and cosine,
yes, yes, exactly. So it becomes half cosine pi by 4.
become more complex.
Well, let's see. Okay. What is cosine pi by 4? 1 over square root of 2 plus j 1 over square root of 2. Or if you guys have, if that's better, we can use the other form. Square root of 2 over 2 square root of 2 over 2. Right? This is equal to square root of 2 over 4 plus j square root of 2 over 4, or square root of 2 over 4 into 1 plus j. Now if I ask you what is the real part of a2, you will say it is square root of 2 over 4. What is the imaginary part?
Same.
1 plus j.
1, 1.
No, square of 2 divided by 4.
Exactly, this is the imaginary part. Okay. I mean, don't forget this. I mean, you are just looking at this. So the reason we converted it into this form is to make sure that we can see the real and imaginary parts, right? Because it's a complex number. By looking at this, it's difficult for you to tell what is the real part and what is the imaginary part, because it's a complex number. So it's, or if you don't want to convert it, then you can directly say that it is in the polar form. So we can say that, and if you compare it with the r e to the power j theta, so you can say that the magnitude is, which is r, is equal to half, and the phase, which is actually the theta, this is equal to pi by 4. You can do it this way as well. Okay, so either you do it this way, real or imaginary part, or you do it this way, but depends. And like if I give you this question in the exam and I ask you what is the imaginary part of this signal, so you will have to use this form, right? Because how the question can come. Okay, I can ask you that, okay, this is your signal. Let me go back. Yeah, this is the signal, right? And I say, given the following signal, find the Fourier series coefficients and answer the following questions. Okay, and then I can say the value of a0 is, you will say 1. Okay, or I can say the imaginary part of a minus 2 is, right? So that means I'm asking basically this. This is the imaginary part of a2, right? And for a minus 2, it is this minus 22. All right, so that's why it's important to know how to convert these complex numbers into different forms. Okay, so that means that this signal has 1, 2, 3, 4, and 5. 5 Fourier series coefficients. Okay, and all their coefficients are 0. Whenever the value of k is greater than 2, either on the positive side or on the negative side, the value of a is 0. Right, and since it's a complex number, okay, so it's a complex number. So if I want to plot this complex number, I have to give two plots. Okay, by two plots we mean that oh, you're not seeing the slide. I didn't realize. So what I'm saying is that for this for these complex numbers, if you want to plot them, you have to plot it you have to give two plots, right? So whenever you have to plot a complex number, you need two plots. Either you plot number 1 will have real part, and plot number 2 will have imaginary part. I'll show you how to plot. Or you can have plot number 1 magnitude of the complex number, and plot number 2 will have the phase of the complex number, right? And how is that going to be? It's going to be like this, right? Now here you see, this is the magnitude. That's why he's showing the 2 mods. So magnitude, right? So this is A0, which is 1. This is the real part of A1. This is the real part of A2. And all other A's are 0. Similar on the left side, this is the real part of A minus 1, real part of A minus 2, right? Now, if you look at this one, this is the phase. This is the symbol, you know, this angle. This is the phase or angle of this. So you can see that the phase of 1 is 0, right? The frequency or the angle of the A0 is 0. So that's why you see a 0. And this is the imaginary part of A1, imaginary part of A2, and rest are 0. Similarly, on the left side, imaginary part of A minus 1 and imaginary part of A minus 2. All right. Is it clear? Any questions?
Yeah, Doctor.
Go ahead.
This is the face. It's become from the relation tan inverse of x and
Yes,
y.
yes. Exactly. No, those basic things. I mean, remember the exam 1, I gave some questions of that type as well, right? If you have a complex number, x plus jy, and you want to convert it into magnitude and phase, so the magnitude is going to be square root of x squared plus y squared, and the phase of z is going to be tangent inverse of y over x. Okay. All right. Any other question? All right. So then let's stop here. Okay. And inshallah we'll meet again next Monday.
Doctor,
Go ahead.
I'm Muhammad
Inshallah.
Zahran. I will have a problem in beginning of
Yeah.
the
Okay.
lecture.
Okay. Yeah. Is there a question about the technical material, technical stuff?
Okay, everything is clear.
Doctor, I have a question, please.
Sure. Go ahead.
When you see the exam, it was x of t. Okay.
The example? Yeah. Okay.
Yeah, it was x of t, and when we plot it like x of n. Why is this?
No. Okay. It's a good question. MashaAllah. Very good. Your observation is very good. Okay. Let me show you. If you go back, this is x of t. Hold on. This is x of t, right? So this is your signal. So it's a continuous time signal, right? Agreed? But when you take its Fourier series, the Fourier series is discrete time. That's why the plot is like this, right? These are the coefficients of Fourier series. Okay, so basically what it tells you that you have a sine wave which has a frequency of 0. You have another sine wave which has a frequency of omega naught. You have another sine wave which has a frequency of 2 omega naught, right? So that's why you see discrete, it is discrete, but the signal itself is continuous time. Did you get it?
Yes. And about the one, is it also sine wave?
Well, it's a sine wave, but with a 0 frequency, like this. If you look at the previous problem that we saw, it is like this. Okay, so you can say it's a sine wave, but with a 0 frequency.
I consider also periodic.
No, it's not periodic. It's
Okay.
not periodic. Yeah, it has an infinite period here. But it's a kind of a special case, I would say. It's a DC, right? What it does, it basically shifts your signal from 0 to some upper value. Like if you look at this one, see, it is not symmetric by t, right? I mean, it should have been, if this guy was not there, let's suppose this was not there, then this signal will be a little lower. Like this line, this horizontal line will come in the middle of this signal. but because of this, it is moved up.
It's like C.
It's like C. Yes, exactly. It's like C. Yeah.
Okay.
Is it clear?
Yes, doctor.
Okay. All right. Now here is this guy. Here it is. Okay, the class is finished. If anybody wants to leave, he can leave. Okay, I'm just gonna uh, mark those students who came late. Okay, so one
Doctor,
is Muhammad al-Zahrani. Muhammad al-Zahrani. But you're already present, right? Anybody
Okay.
else?
No,
Yeah.
Doctor.